When most people sit down in front of an AI for the first time, they treat it like a magic 8-ball. They type a question into the text box, hit enter, and wait for the oracle to spit out an answer. But when you ask it to solve a logic puzzle, say the classic 8-sheep riddle, using a simple, direct prompt, the system frequently fails. It spits back a confidently incorrect number. The natural reaction is to assume the technology is just a party trick, or that the models simply aren't advanced enough to handle real reasoning yet. Researchers at Google Brain, however, found that scaling up the raw size of a language model doesn't automatically solve these challenging reasoning tasks. You can add billions of parameters, and the system will still stumble on basic math and logic. The breakdown occurs in our input structure. We are asking direct questions to a system that requires a step-by-step logical path to reach the correct answer. To get around this logic barrier, you have to change how you talk to the model, using a specific technique called chain of thought prompting. Instead of asking for a direct answer, you force the AI to show its work by generating explicit intermediate reasoning steps. Providing a template of this step-by-step reasoning allows the system to calculate the correct intermediate values until it reaches a logically sound conclusion. This data tracks the solve rates for challenging math problems. When you compare standard prompting to chain of thought, you see steep upward trajectories. Large models like the 540 billion parameter Palm move from low solve rates to exceeding previous state-of-the-art systems. There is a second half to this input equation, known as implied context. These are the unstated variables in your head that a human would factor in automatically. Because the AI lacks that background, you have to explicitly surface those details in your prompt to guide its logic. Rigorously structuring your input this way transforms the AI from a passive guessing machine into a targeted analytical engine. Once you know how to talk to these systems, you have to decide where the processing should actually take place. True fluency requires stepping away from default website portals. The ecosystem has 3 tiers. The outer tier features standalone tools like independent chatbots. The middle tier has integrated AI built directly into your word processor. At the core are custom AI solutions, tailored to solve specific problems using specialized data without requiring technical know-how. Choosing the right environment matters. Matching the tool to the task dictates whether the software acts as a clunky distraction or a multiplier of your own output. Even with a structured prompt and a specialized tool, the process isn't complete. Because of the way these models ingest and process information, the data they produce carries specific, predictable risks that require a separate phase of review. Every current AI model shares 3 strict limitations. They inherit systemic biases from their training data, they operate with strict knowledge cutoff dates, and they produce factual hallucinations, where the system confidently fabricates information out of thin air. To mitigate these vulnerabilities, the U.S. government published the NIST AI Risk Management Framework. It acts as a critical standard for evaluating and deploying artificial intelligence safely. The framework's core mandate is that when you deploy these tools in high-stakes environments or critical infrastructure, you cannot rely on blind trust. The system requires an active, rigorous human auditor. If you remove that human oversight and allow a hallucinating system to operate a critical industrial setting, the physical and economic damage scales exponentially. To be a true AI native professional means you never expect the machine to work alone. You structure its reasoning, you dictate its environment, and you relentlessly audit its final output.